ETail system data dictionary is what you're looking at right now on the spreadsheet. We can monitor the list of logical table name have been listed, and we also have a physical name relevantly for the logical name, and the database name have been chosen, which is going to be an ETail for our ETail system, and we have a schema name which is going to be an ETail transaction, so that is ETail underscore TRN. Now, what is this data dictionary is? So in order to understand that, I've already prompted the question to ChatGPT. So let's quickly have a basic understanding of what data dictionary is, and then we will get into the details of different tables and fields that will be a part of the data dictionary that I've already defined and declared in the spreadsheet. So a data dictionary is a structured collection of metadata. So what is metadata? Metadata is nothing but an information about another information. So here the definition says a set of data that describes and gives information about other data. So basically, when we create a data dictionary, we need to keep in mind that we are going to give more detailed definitions or detailed information about every element that's going to be part of a data dictionary. So that could be a table definitions, or it could be a column definitions, or it could be a constraints for the column. So anything that we need to give more detailed information is going to be part of this data dictionary. So why do we need this data dictionary? Is basically because we need to create a robust database system for this ETail application. The data dictionary is going to be acted like a reference guide or a documentation that explains the meaning, structure, and characteristics of the data that is going to be used in an organization. So basically, we are going to give the definition for the specific data, or could be a structure of the data that need to be defined in the data dictionary. So here is where I have created a data dictionary for the ETail system, an online e-commerce platform. So here you can have a look at it. There are 13 tables which I have listed here, and these 13 tables are going to have more detailed informations in it. So before we get into the table informations, just have a look at it. So database name that we are going to follow in order to develop this ETail system is going to be ETail, wherein the schema name for that is going to be ETail underscore TRN. TRN stands for transaction. So any transactional data will be flowed into this schema via the schema. So it is ETail underscore TRN. If in case we are going to have a reporting data, then probably it's not a transactional data. It's going to be called as an historical data. Then probably we'll give a schema name as ETail underscore RPT. Let's consider that as a report. But right now, we are not going to focus on the report schema, wherein we are going to focus on the transactional data. So in that case, we need to have a naming convention like ETail underscore TRN. And one more thing that you need to notice here is the table name, the logical table names are listed here. So that is like user, buyer, seller, address, and so on. But if you look at the physical name, I've just given the table name as USR. BYR means it's buyer. USR means it's user. SLR means it's seller. So why can't we use the name to be same as a logical name? Can't we use user table as USER and buyer table as BUYER? Yes, of course we can do it. So most of the table names that you come across in on online or on GitHub platforms, probably you will be seeing the names as user, buyer, and seller as the logical name to be given for the physical name as well. But as far as my experience is concerned, when I was working for a real-time application development, we never followed the same logical naming standards. So we have a specific naming standards where each organization will follow. So I'm more inclined to the standard in which where we will officially use those terms. So we never use user as user, wherein we will call it as USR as in the table name. The same way, if you look at the home address, I've just defined as HM. HM refers to home and ADRS refers to address. So like which we have some list of naming conventions for every word. So almost like 4,000, 5,000 words are already been predefined, and we will be following those naming conventions while we are naming the table names, or it could be for a column name as it matter. So if you look at the product table, we have PRDT as in the table name, but I'm not going to call it as PRODUCT as in a name. So logical names are listed out here. This is only a logical name, wherein in physical, the table name is going to be pronounced as USR, BYR, and SLR. So similar naming standards is what we are going to follow for the column names as well. So we'll straight away get into the list of all tables for this 13 table structure. So right now you are looking at the complete 13 table structure. Is this ETL system is going to have only 13 tables? No, not exactly. It might have 20 plus tables or 25 plus tables, which I'm not sure exactly, because as we grow along the development of the application, we might be adding more tables. But these are the first level list of tables that we need in order to develop this ETL system. So if you look at this 13 tables, so here is where the complete data dictionary information for each table is listed. So the first one is the user table, as you can notice. So here again we have the logical field name, and we have a physical field name. So look at the logical field name email. I have just given my physical name as EML. So email column will be pronounced as EML column here. So if you look at the first name, it's FRST_NM. So there are two words as part of this logical name. So we need to separate them with an underscore. And if you look at the user identifier, it is called as USR_ID. You can also notice that I have highlighted the primary key column here with red color and denoted with PK. So PK means it's primary key. So what it means is this gives more information about the columns as well, and the constraints it holds, and what data type it falls under, and whether the column accepts null or not. So that is nullable or not. We can also have the length of each column, but I have added the length along with this data type itself. But we can have a separate column called length and add the length for each and every column as well. So here you can see the physical name of the table, and the logical name of the table, and the physical name is also given here. So like which for all the 13 tables, I have given a more detailed informations about each and every columns and its constraints. So if you look at the buyer table, which is going to refer to the user table. So user table is going to be acted as a parent table, wherein the buyer is going to depend on that parent table. So for that, we have defined a user ID of the parent table column and referring it via the foreign key reference. So foreign key references will be defined like this. The column name in this table is USR_ID, and it's going to be acted as a foreign key mapped to which table? It is mapped to USR table. But does this table have a primary key? Yes, of course. Buyer identifier, BYR_ID. All identifier name will be called as ID in physical naming standard. And this is again a primary key. So the color is red, wherein here the foreign key color is defined here. So like which I followed consistently across all tables, all 13 tables. You will be coming across seeing the foreign key references and as well as the primary key references, and which table it depends on will also be highlighted in the foreign key detail. So if you look at the product table, you can notice that the product table is depending on two further tables. So one is the seller identifier, another one is the category identifier, which is the seller table and the category table. Like which we also have an order table, where order table is going to depend on three further tables. One is the user table and payment table and the shipment table. I'm not going more in detail about it. As we go along with the development of each and every table physically in the database, we'll be getting into understanding of each and every constraints and its relevant columns and the data types. So here I just want to give you an overview of how a data dictionary would look like, and what is the importance of creating a data dictionary. So based on this data dictionary only, we'll be going further to create a script, the SQL script, and we will be executing the SQL script in order to create the table, basically the DDL, data definition language, as the first part. So we'll create a database, we'll create a schema, and then we'll create a table, and we will ensure that the relationship also is enabled between the tables. So quickly, we'll just go ahead and see the user table. So if you look at the user table here, we have the logical name, physical name, data type, the nullable status of each and every column, and more importantly, the description. That's what the data dictionary is all about, right? So each and every column, we need to give a piece of information about that column. So what is that column is all about? And via this description, we'll be able to understand how this column is going to be related to the fields in our application. So we need to have a description, but in physical database, we will call it as a comments. So we'll be adding comments, and the comments are nothing but the descriptions. In data dictionary, it's going to be called as a descriptions, whereas in physical database, like PostgreSQL is what we are going to use, there we will be calling it as comments. So similarly, we have for buyer, I have given the detailed description for each and every column. The same way we have for seller, address, home address, shipping address, and so on. With that, we'll be able to see a physical appearance for this data dictionary that we have defined.